for me to make it bigger here so I can see it better? Good, thanks. If you have time, you're not interrupting, can you count people sitting at some point? Okay, folks, let's make a start. As you probably already know, as part of this course, we get you to do a project, and we've very cleverly designed this such that it scales properly, because there's a lot of you, and it's all very well. Originally, when we used to do this, we used to have all of the teams at the end do individual presentations. Fortunately, that's not really possible anymore, because there's too many of you. But the project still works, partly because it's a little bit competitive, so you're going to build a system, and we're actually going to play these systems against all the teams, and so we can actually find out which team is doing best. Okay, we'll come back to that, how that evaluation is going to come back later. Okay, it is a project. You'll be in teams of 4. Okay, and yes, it's okay if you don't know anybody else in the class. We will arrange, and probably already have arranged, that you can find the names of the other people and you can join up into teams. But I'm going to give a little bit of background of what we're trying to get to do here and give some guidelines about how you might actually even go and solve this. Okay? What you're going to do is you're going to build a question answering system. Now, you've probably heard of this before. People do question answering. It's a big topic in NLP. Google does it all the time. I'm trying to get it. The Amazon Alexa does question answering all the time. And it's like that, but slightly different. It's a little bit more constrained than solving all possible questions and giving answers. Okay. What we're going to do is not get you to just generate the answers. We're going to get you to generate the questions as well. So given a Wikipedia entry, because that's a good example of pretty standardized, well-edited text, what you're going to do is you're going to be asked to generate N questions from it. Okay? So you won't know these Wikipedia entries in advance, but you'll have some examples, and they're going to be good Wikipedia entries by some definition of good. And they're all going to be into some sort of genre. So they might be about cities, they might be about philosophers, they might be about movies. So you're not going to get, weird single entry Wikipedia articles that don't look like anything else. Like the one on the USA, it's bigger than anything else, or the one on Pokemon characters, it's also not like anything else. Okay, actually Pokemon characters are quite good because there's a Wikipedia page for each Pokemon character. Possibly, but I don't think we're going to do Wikipedia. But you're going to get given a Wikipedia, so a well-written, deliberately informative piece of text, and you've to generate questions for it, okay, that can be answered by that text, not things that are related to what the article is, but things that have answers in that Wikipedia article, okay? And then the second part of what you'll be doing is you'll be given a Wikipedia article and a bunch of questions You have to answer these questions. Now, of course, what we're going to do is we're going to take whatever you come up with questions for the first one and feed them to your systems for the second one. And much more importantly, the questions that get generated from part one, you're going to have to answer them, and these questions will come from other teams. Some of them may come from you, but they're going to come from other teams. Okay? So, depending on what other teams generate for questions, you should be able to answer them. But, of course, you can't secretly encode information in your questions so that you can answer them, okay, unless you all conspire together to be able to do that, okay, and we'll notice that, probably, if you all conspire, unless you're really, really clever and it doesn't matter, and you can write a paper afterwards about how you conspired to join together to beat the professors, and if it's really interesting, you still get a good score, and don't even try to do that. So, a Wikipedia entry, give me N questions, and you're constantly going to ask me, what is the size of N? Okay? And I'm going to constrain that a little bit for you. It will not be negative. Okay? And it's going to be bigger than 0, is fact, as well. A negative one would be good, so it means that you have to say, oh, I won't mind, it's 5. 5 of the questions from some other team disappear. You know? No, it'll be bigger than 0, and definitely bigger than 5, okay? It will not be bigger than 1,000, okay? But we're going to do that, and the questions that you give should probably be ordered, in that we're going to assume that the ones nearer the beginning are better questions than the ones nearer the end, by some definition of what you want to call better. But you are going to have to care about the ordering of them, okay? So in the same way that we're going to give you these questions, we're going to ask for questions, we're going to give you the questions, and you have to answer them all. And you'll get quite a lot of them, because we're going to sample them across not all teams that you won't have to do it, but there'll be a fair number that you'll have to do. The reason we pick this particular project is because this, to do well, this requires quite a significant use of things that are in this course. And so that's why we're doing it. We're actually trying to work out ways to be able to, so you can show off the knowledge that you've learned in this course, because many of the things that we're doing in the course, not all, but many of the things are going to help you to do a better system to do this. So let's actually talk a little bit about that, okay? Let's talk about what might be a good question. So here's an entry, okay? It might actually be old, but it's about Pittsburgh, and it has a bunch of information about Pittsburgh. It's sort of the first paragraph, and it gives you a bunch of things about what Pittsburgh is, how to pronounce it, a little bit, it's in the Commonwealth of Pennsylvania. I'm sure you knew that we're in a Commonwealth. The United States, it's the county seat of the Allegheny County. In fact, Allegheny County and Pittsburgh really drastically overlap. This is not unusual in the US, where counties and cities are almost the same. And it gives you a bunch of information about it. It gives a bunch of information about, what's it known as the Steel City and the City of Bridges. And so this is informative, okay? Now, given this information about Pittsburgh and not things that you know about Pittsburgh, okay, can somebody give me a question that would be reasonable given this paragraph, that could be answered given this paragraph? Can somebody give me a question? Where is Pittsburgh? Okay, so where is Pittsburgh is a good thing. Okay, it's definitely answered in the first sentence. So Pittsburgh is a city in the Commonwealth of Pennsylvania, optionally in the United States. Okay?
What county is Pittsburgh in?
What county is Pittsburgh in? And so you have to sort of work that out. It doesn't say Pittsburgh is in the county of Allegheny, but it says that it's the, what do you call it, the seat of Allegheny County. So you have to know that the word seat means what you're talking about is in there. It could be that it says to the north of Allegheny County, and then that wouldn't be the case. But that's a good example of something which is not directly in there, but it's in there, and it has that. And of course, if you just go and look for the word county and find the word Allegheny before it, you might actually get the answer. So some other Questions? Yeah.
What is Pittsburgh?
What is Pittsburgh? And so, it's a deep philosophical question. But remember, you have to answer the things that are in there. You're not to take the full philosophical aspect of really asking the question about having, you get to live here for 5 years and you then have to ask, what is Pittsburgh, and the answer is, all night panic to be able to get my homeworks in on time. That's not what you have to think about Pittsburgh at all, okay? So, can somebody else give me an answer to that? What is Pittsburgh?
A city.
Pittsburgh is a city, okay? That's sort of a reasonable answer. It might not be what a human would do as such if you didn't see this. It's what is Pittsburgh, but yes, that's a good thing. And notice that most of what we're talking about for answers are somewhat extractive. So they're looking for a piece of text in all of the piece of text, and then using that to be able to generate an answer. Okay, so that's what the answers actually are. And for the most part, answers are going to be extractive. So there's some extract out of the whole paragraph that's going to give the answer. Okay? Now, let's see if we can come up with a question which is not directly extractive from that data. So there's something you have to work out from the information.
Which city has the largest population in Pennsylvania?
I'm not sure it says that.
It says that, but it might take a little bit reasoning.
So it says the second largest.
The second largest?
Oh, it does say after Philadelphia. Okay, so yes, that's a good point. So you actually have to work out which second largest. Yeah, thank you, that is a good one. Where Philadelphia is mentioned, but you actually have to work out what it means to be second largest and know that that's an ordering and a position, and therefore you have to try and find something. Now, again, there's horrible tricks that sometimes work, where you just look for the sentence where it's got something about population, or look for the name of either it is or is not, and look for the name of some other random city in there, and therefore you come up with the city of Allegheny. There's probably a town Allegheny somewhere, probably, although I can't think where it is. It's probably in Ohio, actually. Random names of cities from all over the world are in Ohio, always. Okay? It's a general rule I've discovered about this country, and clearly by the time they got this far west, they ran out of popular names for cities, and therefore had to start looking at a list and going, okay, we've got to have something called Cairo, or we've got to have something called Toledo, that are really places somewhere else, rather than New England. It's a whole bunch of places in England that, are very confusing to me. Anyway, so yes, that's a good example of something which is mentioned, but it's not simply extracted. You have to work out. So that'd be quite a hard question and a hard thing to answer. We have another one that would require a little bit of understanding of what's going on.
Say, is Pittsburgh an old city?
Is Pittsburgh an old city? Now, that's a good question as well, because you have to have a definition of old, okay? I come from the United Kingdom, okay? One of my former offices was considered to be in the new town of Edinburgh, and it was 350 years old, okay? Because that really is quite new compared to when I had an office in the old town, and it was 900 years old, okay? And I'd just like to say it'd been, leaking with rain for more than 800 years, that office. But the notion of old is going to be dependent on where you are, and old in the US and definitely towards the east. Once you're older than 100, maybe 150, it's probably old. And does it have that information in there? So it doesn't talk about when it was founded, which was something like 1740 something, if I remember correctly. And so it might not be able to tell you in a reasonable way about it.
It talked about Civil War leaders.
Oh, it talks about Civil War, thank you, yes. So yes, and so if you know when the Civil War was, then you could actually work out that there was something about it. San Francisco was not involved in the Civil War, okay? At least not the one on the East Coast. It had other battles that were probably in Spanish, okay? Where is Pittsburgh? What's the population of Pittsburgh? What's Pittsburgh's nickname? There's actually two things in it. How many steel-related businesses are there, and are they still there? what does a city feature? All of these are things that have some abstractive information that we can actually get out directly out of the data. Okay. Now I want to make sure that we're asking what I'm going to call sensible questions, because you're all a bunch of computer scientists, completely understand that you can come up with things which are questions that have answers that are unreasonable for this piece of work. Okay? Yes, they're reasonable. Okay? So things like, you know, how many words are in the article is a completely reasonable question. That is a very clear answer. And no, we don't want to do things like that. Okay? The boundary of these things gets a little awkward, but, you know, no. Okay? We want to do something that our people who are not proficient programmers are going to come up with. Okay? So can somebody give me other questions like that that we do not want the answers for? A question that, yes?
How many white spaces are there?
How many?
White spaces?
How many white spaces? Yes, how many white spaces are there? Okay. How many capital letters are there? Okay. If you take the prime valued letters out of it, what words can you make? So.
How many times does Pittsburgh appear in the article about Pittsburgh?
Yes. So even though that actually might be quite a sensible thing to do, because what you could do is you could look at different entries in Wikipedia for different cities and look at the number of times that that name actually appears. And what you don't understand is Los Angeles appears once, okay, because it's called LA all the way through the article. But, you know, yes, it's a reasonable thing to do, but that's not the type of question that we're actually using. We're not talking about these counting type things, but it might be quite reasonable if the entry said something like, you know, Pittsburgh is famous for 3 things, and then names 3 things. Okay, so you might be able to get away with doing something like that. But it'd be quite hard to generally do that when you don't see, your program won't know what the article is until it's running. Okay, so you won't be able to tune your code for the particular entry, okay, the particular article. Okay, so yeah, there's a bunch of things that can be done. What's the capital of France is a perfectly reasonable question. That's a perfectly reasonable answer. But it's not appropriate for this particular article. Okay, so please don't do that. Actually, in general, here's a trick. When you're testing somebody's question-answer system, you should always type in what's the capital of France as the first question. Okay, and if you're providing answers for a question-answering system and your system doesn't work, always provide Paris. Okay, because that's the most common question people do when they're testing a question-answer system. Okay, but that won't work here because we know what Wikipedia entry. What's the 57th letter of the article? We could also ask what are Pittsburgh's 3 rivers. That's a little hard. They are all mentioned in the article, but maybe not explicitly. So that's something that, and arguably, well, you know, one is Forn by the Allegheny and the Monongahela. It's not really another river, it's a confluence of a river, so it's not really 3 different rivers. So let's talk a little bit about how we might actually do that, okay? How we'd actually find questions. I'm not talking about the answers, I'm talking about the questions, okay? So you can look through the article and try and find places where there's X is Y. So you have an X and you have a Y. And then what you could do is you could, let's say, you ask the question, what is Y? Okay, but that might give you some silly things. Because you say, what is a city? Because it said Pittsburgh is a city. Okay, but you could say, what is Pittsburgh? And the answer is Pittsburgh is a city, and that will be okay. When you're generating questions, though, with the what, sometimes you don't want a what, you want a why, or you want a who, or you want a when. Okay, so depending on the thing that you've cut out, the type of X or Y, you might want to care if it's a place, if it's a reason, if it's a person, or if it's a date, a year. Okay, when was Abraham Lincoln born? Okay, so also if you have the X, some verbs Y, you could actually reform that as a sentence that says, what does the X verb? Okay. So if it's something like Pittsburgh or the city makes steel, you can ask the question, what does Pittsburgh make? Okay. Now, notice that in the original form it said makes, with an S at the end of it, okay, and yet in the question it changes morphological form and becomes make. The S gets deleted, okay. That's important, okay, because that's part of the language and you want to get that right, and although it might still be understandable, it's not fluent, and we do care about that. We care about getting both grammatically and morphologically correct forms, and that's quite productive because we know what the different forms of the verb are going to be and how they change when you do that manipulation. So we can do that, okay? And that's something that we want to care about. Number questions are quite good. So if it says that Pittsburgh was founded in 1746, then it's quite reasonable to ask when was Pittsburgh founded with a number, so you could look and find all of the numbers, try to work out if they're reasonable numbers, dates, because we know something about what the range of dates are probably going to be. We might know if there's a particular point in the so it's not just a year, but there's a date, 5th of November, and so we could actually try to do that. Sometimes it might be arithmetic that's required on numbers, and that's actually quite hard to generically deal with, okay? So maybe you don't do it, but if there's a simple number, okay, then that might be a reasonable thing to do. What's the height of Everest? You want to go and look for something that tells you how high Everest is, okay? So these are pretty easy things to deal with first, and it's a good idea to actually deal with those first, because you're going to do this project over most of the semester, and so that's a good starting form to actually care about. The reverse, how to answer the questions, is again that we've got something like what is y, and so what you want to look for is x is y, okay, through the data. So you take the question, you do a little bit of syntactic manipulation on it, and you go and look for the thing, and then find out whether the thing that was missing, the x, is of the type of the what, when, why, okay? And that's a reasonable thing to do, okay? Almost always, the easy questions with the easy answers are going to be extractive. You're going to find the sentence that's got the most information in. And there's little syntactic manipulations that happen, the makes, or it might say, you know, Abraham Lincoln, who was born in, oh my God, I have no idea when Abraham Lincoln was born. 1813. Nobody's going to correct me. Nobody's looking it up quickly now. Okay, well, let's pretend it's 1813 and avoid my embarrassment of not actually knowing. Who was born in 1813, okay, or Abraham Lincoln, comma, born in 1813, okay, so it's not is born or was born, it's just got that, you know, was president during the Civil War, okay, so we may have a relative clause that gives a piece of information rather than a full sentence. And so that's a good thing to consider as well, to see if we can actually extract questions out of it, okay? But remembering that there may be small changes that are required in order to be able to answer it, because we want things to be nice. For example, if the question was that we had was, what is Pittsburgh, okay? And you could answer, according to that, Pittsburgh is a city. You could also answer, Pittsburgh is a city in southwestern Pennsylvania, in the Commonwealth of Pennsylvania in the United States. That's also an answer. Also, there's another answer. What's Pittsburgh? You could go, here's a whole paragraph, okay? And that describes what Pittsburgh is. So technically it's an answer. Okay, in fact, that's probably the answer for every question. But that's too much information. It's not the right piece of information. So think about having both the answer being there and being sensible and not having more than what's necessary for the answer, or sometimes too short, okay? You know, who was Abraham Lincoln? And if the article says Abraham Lincoln was an American born in 1813, you don't want to answer Abraham Lincoln was an American. Completely true, but it's not really the answer to the question by some definition of who. Okay. How do you know your questions are good? Okay? Because you're going to write a piece of code that generates questions, and you've got to come up with a way of finding out which ones are good and which ones are bad. Come the actual evaluation, you will not be allowed to individually look at the questions that get generated. You're going to have a piece of code that tries to evaluate which questions are good and which questions are bad. Okay? And so now you have to care about, how do I know when it's good English? How do I know when it's bad English? How do I know when this is just silly? When do I know when it might be silly but I don't know? You know, if it's too short, if it's too long, things like that are usually a good idea to look at. Okay? So one of the things you're probably going to have to care about is sort of two things. One is it's sort of grammatically fluent. Okay? Can you parse it with a parser? Can you try to work out what questions should look like, and does it look like a question? Okay? And is it also reasonable? Okay? What is not a very good question, even though it might be answered in the particular article. Okay? So sort of these two dimensions: is it grammatical and is it reasonable? And you have to come up with a way to measure that. Almost certainly, you know, I'm going to ask you for these questions, so number, you're going to have lots of different ways of getting questions, and you really want to choose the most interestingly hard ones that you can answer that the other teams cannot, okay? But you don't want to screw up and just generate ridiculously hard ones that only you can do, because people might think they're not reasonable questions. So you want to have some easy questions, some hard questions, and some maybe super hard questions that you're particularly good at that are interesting. And you want to be able to sort out which ones are good examples of that and which ones are bad examples of that. So you want to be able to have some measure of which of these are considered to be good and which of these are considered to be bad. So you've got to come up with an automatic measure so you can rank what these questions are going to be. Okay? So really what it comes down to, we are going to give you a text of Wikipedia article, okay, and an integer, bigger than 0, smaller than 1,000, and you're going to output n distinct questions about the article that should be fluent and reasonable. So we're going to run it something like this, where n is a number. Okay? You must, when I say must, I mean absolutely unquestionably must, otherwise everything breaks. Output one question per line, okay, on the output, and not output anything else whatsoever on standard output, okay? You're not allowed to do that because it breaks everything, okay? If it outputs, you know, found 5,300 different questions, then that will get used as a question and it will break everything. So please do not do that, because it's very annoying. You will be marked down if you do that. One of the requirements is nothing apart from the output. And then what happens if I ask for 999 questions and you can only find 998? Okay, repeat the last one. Okay, or something like so. Always guaranteed, or just what? Question mark. You know, always a good question. What is the capital of France? No, don't do that. Okay. So you want to be conform to the requirements, because we run these things automatically. I'll come to how we're going to do that. We run these things automatically, and if they don't follow the spec, it really breaks everything, okay? And what you get is the people running, the TAs are running it, get, you know, really happy about it, and they really enjoy going in and looking at funny pieces of code while it doesn't work, okay? Did I say enjoy? I don't think that's the right word, okay? But you get the feeling, okay, about that. We'll give you some examples, okay, to work on, and we will follow a number of different domains, okay? So there'll be a bunch of things that are about, for example, some of the things we've done in previous years: cities, philosophers, movies. And maybe it's sort of worth trying to detect when the article is about a movie. If it is about a movie, there's a bunch of movie-type things you could try to answer, ask questions about. Maybe. Okay? But we'll also give you sets of things that you've never seen before. Okay, they're still from Wikipedia, but they're from some other part of Wikipedia. Though, you know, really when it comes down to it, it might still be about a person. So they probably have a birth date, and they may or may not have a death date. And you're not allowed to predict when they're going to die, okay? Especially if you're right, because that's a little worrying if you start predicting when people are going to die in the future, okay? Oh, and I should say, that might not be the up-to-date Wikipedia, okay? Because we sometimes mine this stuff from a number of years ago, and we sometimes reuse them. So Donald Trump might not be president in the particular example for Donald Trump, because believe it or not, he was not president at some point in the past. Okay, so don't assume. You have to assume that the article is the piece of information and it's true. Okay, even though it might be out of date with respect to the real world. But you should just deal with the article. So using external information is not really what this is all about. Okay, it's how can you, given a document, extract questions? How can you, given a document and have questions, can you answer it for that particular document, rather than caring about truth in an external sense. Okay. We'll use your program to generate questions. Some of the articles will be ones that you've seen before, or ones that you've actually been in your test set. So you'll have been able to do something pretty reasonable for that. There are going to be similar articles, so we give you a bunch of ones about movies. We'll give you other movies, okay? But we'll also give things that are in another domain. I said that. And we're going to try to work out how fluid and difficult the questions actually are. Now, how do we, as the organizer of this course, actually do that when I've already said it's pretty hard to come up with a measure that tells you this? Do we have a secret measure? Have we asked a whole bunch of students over the last 5 years to come up with measures about which things are good questions, which ones are not good questions? Actually, we have. But no, what we actually do for this is once we get the questions, we split them up into examples and get you people to evaluate them. And so we use you as a bunch of crowd workers to be able to evaluate which of these questions are good or not. And it won't necessarily include your questions, though you might, because some of the questions will repeat. And we ask all of you to be able to give a score of how good you think these questions are from fluency and how good they are from difficulty. Okay? And we use that information to go to the next round to be able to choose which questions that we're actually going to submit to the systems afterwards. Okay? Because you don't really know whether all the questions that you generate are good or not, especially if it's an article that you've never seen before. Okay? And so we're just going to have all of you provide a score for these. And so we get the score about how good your questions actually are. And that's again how this project actually scales, because the more teams there are, the more people there are to actually do that. It's a fast turnaround, you should be aware of that, but you have to do that, and we don't give a full week to do that because we really want to do that in a couple of days. Okay, so once we have the questions, we then do the question answering. And this is the more traditional NLP task that you've probably used before. Instead of generating questions, you're generating answers to questions. Now, of course, these questions are all machine generated, which makes them a little artificial, okay? But they probably do have real answers in the articles, which is not always true for human generated questions, because humans always come up with cool and interesting things that it's quite hard for them to be constrained to the piece of text that's in front of them. We'll give you a Wikipedia article, and we'll give you a list of questions, one per line. That's where the one per line is really important, okay, for the questions that get generated. One per line. The ones that you get will come from both your system and from other systems, randomly selected. The answer to the questions should be fluent, okay, so they should be grammatically fluent. They should be correct with respect to the article that's there, not necessarily correct in the real world, but just correct to the article that's actually there. So they should be somewhere in the text of the article or very nearly in the text of the article that can give you that answer. And they should be intelligent human-like, okay? So we actually do care about that. So this technical thing of saying Abraham Lincoln is an American, yeah, but that's not really what the question was, okay? If there's some more specific, better answer, then that's what we're looking for. It sort of sorts itself out. You might think, oh, that's really unfair, but it's really unfair for everybody, okay? So it's equally unfair over everybody, because it might be that there's some obvious piece of text that looks like it's the answer, but really it's somewhere else, okay? So that's what we're looking at. And again, we use you to do the final evaluation, okay? So we take the answers for these, we give you the article, the question, and the answer, and we ask you to score them to tell us how good they are, so we can very quickly find out which team is actually doing the best. Okay, this works pretty well. Okay, and although there might be some variance in the measure when teams are very similar or teams are very bad, in general this is pretty good and pretty fair way of actually trying to measure. And remember, you're not like the general population, because one, you'll have built a system, and so you'll understand why some of these answers are there, and you might actually go, well, you know, that's close, and I think that's okay. Well, if you actually ask some random person in the street, they go, no, that's stupid, that's not the answer at all. But you're going to be a little bit more discriminatory with your answers, because you understand what the task is better than what the end user actually might be, but it's still a good way to actually measure. Okay. So we'll give you a bunch of, again, articles that you can work with questions. We'll give you some sample questions from previous years, but you've got your own questions that you're going to generate, and it's always a good idea to test your system on your own questions, because you can't answer your own questions, you're probably not doing very well. Well, maybe, but you know, you're going to have teams of 4, and often there's some split into those who do questions and those who do answers, and it's good to have that split, but you want to make sure that the question generating people are generating test questions for the people who are doing answering quite quickly, so that you can actually work out whether you're doing reasonably or not. Okay? And you also probably want to have some way of evaluating with example answers. One of the best ways to do this is pretty early on, really very early on. Maybe even by hand, you take an article and all of you come up with 5 questions from it. Not writing a piece of code to do it, you just do it by hand, and you come up with what the answers would be. And so you've now got a test set with a bunch of questions and a bunch of answers. Not done automatically, okay, just done by you, and then you start using that as your test set, okay? And so you should design your questions to be relatively simple and the answers to be relatively obvious, so you can at least probably achieve these question answers, and you can start evaluating your system, and the first time you actually run, you're going to be so pleased. It's like, I've got 20 questions and answers out of this, and I got 2 correct, woohoo, okay? Hopefully you'll get better over time, and then you can delete the ones that you hand crafted to have ones that you automatically generated, and hopefully your score will get better with respect to that. You'll probably never get 100% of them correct, okay? Probably not, because it's really hard, and that's actually what makes it interesting from a natural language point of view. This sounds very easy to specify what it is, but actually the way humans write text is often more complex than it needs to be, such that it's hard to automatically select questions, and it's hard to automatically give answers. This is something you're going to discover by looking at this, that it's a little bit harder than what you think it is. And imagine that you're actually working at Amazon and you're trying to actually answer the questions that come in on the Amazon Alexa, and you have all these questions that come in, and you have all of the Wikipedia articles pre-processed in a way that actually allows you to get these questions, and then people are going to come along and ask these questions that you think, how on earth am I ever going to answer that question? They're going to ask things like, you know, who's the star of the first Star Wars movie, and you have to get answered. Yeah, Wikipedia's got that, you know, but who's the best actor? That's sort of hard. Okay, although there probably is a list of so-called best actors somewhere in Wikipedia, somewhere that somebody has voted for, and maybe you could give the answer to that. Okay, but you know, people ask really funny questions. Okay, But in general, if they have a good answer, you should be able to give a good answer, and that's why we're actually doing this as a project. Okay. So the first thing you have to do is form a team. Okay. We have done this over a number of years, and because of that background, you must have 4 people in your team. Okay, it's quite a lot of work. Okay, and although one person, okay, can actually build a whole system in a semester to do it, it's unfair that only one person actually does that. A team of 50 people can do it too, but realistically only 4 people will actually work on it. And so we've decided that 4 is the right number. It's big enough that actually it requires you to communicate with each other, okay, which we think is a good piece of extra education in this class, that you learn to be able to build an NLP system by working with 3 other people, and therefore we've decided that 4 is the right number. So please make teams of 4. Okay, so somebody sitting in the back row who's just worked out the number of people in the class, mod 4, and realised that there's only a leftover for 3, and therefore there's going to be a team of 3. The answer is, by the time that you've actually made your teams, the number of people in the class will have changed a little bit, and therefore there won't be 3. But yes, no, it's not going to be divided evenly by 4. We're not going to say to the person sitting at the top right, you can't be in the class because there's only one of you. We're not going to do that, okay? But really form a team of 4. And during the semester, things change, and we're aware of that, okay? Please let me, David, and the TAs know if anybody in your class, in your team, actually drops, okay? And for 3, depending on what's happened, you can continue. Definitely near the end, we don't make changes. But once you drop down to 2, we make changes because it's unfair for you to continue with 2. In fact, we're a little worried that those teams that had 2 and joined together have got 2 ways of generating questions, and actually they do quite well. So even though you've changed your team members, you've had you get a little benefit from the fact that you independently develop them. But 4 is it. Now, you're all going to say, but I only have 2 friends in the world, okay, and I don't know 4 friends. Okay? And we will find you another friend. No, we'll find you another teammate. No guarantee another friend. Okay? But we will find you other teammates, and if you don't know anybody, we'll find you teammates as well. So we'll actually have a clearing, so it allows you to do. But there is this technique, okay, of actually finding team members. Is what you do is you turn to the person next to you and behind you and say, "Are you in a team yet?" Okay, and it's called speech. Okay, and yeah, you can post to Piazza because I know that you don't speak. There's only communication by chatbots. But please do that, and we'll give you a little bit of time at the end of this lecture to actually put that together. Okay, it's a really good idea to build a question generator first. Okay. I would say that in general, answer systems are a little bit more studied than question generation systems. Okay, so if you look for question systems, you'll find answer systems. Okay, on the net, and I'll talk a little bit about what external things you can use and what you can't. But question generation is a little harder. There's less people worked on it. There are people who've worked on it, and you want to do that first, and you want to get a very simple system work. Something that just actually works and generates questions that are not stupid, that could be answered, even if you think they're really simple. That alone actually takes quite a lot of the time. Once you have that, you can start trying to do things that are harder than that. It's a good idea to soon start generating questions. Okay. And in fact, we even have a requirement that you do that very early on, before, it's not spring break, autumn break, mid-semester, we call it. You're probably going to build a pipeline, okay, and there's going to be a bunch of things. The naive idea of I'm just going to take whatever text is there, I'm going to stuff it into any neural net and be able to train it probably won't work, mainly because you don't have enough data. Theoretically it would work if you did have enough data, but you don't have enough data, and if you did have enough data, you won't have enough GPUs. So you want to actually build a pipeline to make this more structured, because that's actually what we're testing here, and I'll come to that in a minute. We really are trying to test how you build an NLP system from these individual components. The first thing you're going to analyze the article. You're going to take the article and you're going to do some analysis on it. Okay? You're going to split it into sentences, and you're going to try to analyze these sentences in such a way that you might throw them away or keep them, and you might say, I'm going to exclude everything that's too long, or everything that's too short, or everything that doesn't end in a period, okay, and has some table in the middle because I don't know where the sentence goes. That's a perfectly reasonable thing to do, and you have to come up with some rules to be able to do that based on the articles that you actually see. Okay? You want to tokenize each of the sentences into words, and you're all going, yeah, what's hard about that? White space. Okay? Now, as you'll see during this course, deciding what a word is incredibly hard. Okay? Those of you who are speakers of Chinese or Thai or Japanese are going to go, yeah, deciding what a word is really, really hard. There's no spaces that are written in those languages between words. But as I pointed out before, there's no spaces in speech either, so you don't need spaces between words to define what they actually are. In the European languages, we traditionally write spaces between the words. So there's white space separator between that one, which might be new line or whatever. But it's not quite as simple as that, because what we also discover very quickly is that we have these things that are sometimes multi-symbol words. So, you know, Los Angeles is a word, but, okay, there's a space in the middle of it. And Los Angeles really doesn't mean the word los and the word angeles, okay, the angels in Spanish. It really doesn't mean that. That would be something different, okay? In the same way that New York is not a new version of the medieval town in the north of England in the middle of Yorkshire. It's actually a completely different place, okay? Don't confuse them. They're both nice places, but they're very different, okay? So New York is a word, and maybe you want to get New York as a word rather than New York. That's actually quite hard to do, okay? So maybe you don't need to do that. Also, there's this horrible thing called punctuation, which really messes things up, and you might think it's really nice that there's a really nice thing called the period that tells you when you're at the end of a sentence. And yeah, apart from it, sometimes it's an exclamation point, sometimes it's a question mark, and sometimes it has double quotes after it, and sometimes a closed parenthesis after it, or maybe if it's in Wikipedia, it then has a citation next to it, and does the citation come before the period or not? Believe me, there's huge arguments about what's actually right, and I bet you there's a style guide in Wikipedia to tell you what's right, but you're going to have to probably strip off punctuation, okay? Because it gets in the way. Okay, years might be in brackets. You probably went rid of the brackets. When was Abraham Lincoln born? Open paren, 1831, closed paren is not the right answer. Okay, so be aware of that. Then there's other things which make tokenization a little harder in English and in some other languages. In French, the article the, usually written as le or la. If the next word starts with a vowel, and the L gets changed into L apostrophe, okay, and then gets concatenated onto it, and so you probably want to separate that. But we want to have, it's going to be primarily English. Yeah, there could be some foreign words in the articles, but most of it is really going to be English. But we have this apostrophe S thing in English, okay, and you should be aware of it. Those people who've never worked in natural language processing think it's part of the word that's attached to it. Okay? Those people who've worked in natural language processing quickly realize that apostrophe S is a completely separate word. And it's a really, really, really good idea to separate it from the words. Okay? This is not obvious until you actually don't do it. So maybe we should get you to not do that and then discover how everything breaks. It doesn't do matching between words because there happens to be an apostrophe S, and you really don't want that. And so you want to be able to separate these things. Apostrophe S is a good idea to look at. What about the other apostrophes? We have N apostrophe T, we have apostrophe LL, we have apostrophe VE. They're productive, they can go into things that have never been there before. For the most part, Wikipedia won't have that because that's considered to be casual, and Wikipedia won't do that, so you maybe don't have to care about that. Maybe. Okay? But maybe you should check it and find out. Once you've got a decision of what the tokenizer is actually going to do, and you have these individual tokens, what you probably would like to do is run a part-of-speech tagger on it. Now, part-of-speech tagger is something that tells you whether it's a noun, verb, adjective, preposition, article, etc. Okay? And there are good existing part-of-speech taggers for English that work pretty well. Okay? Though rather interestingly, the part-of-speech taggers that are out there, most of them have been trained on newspaper text, okay? Particularly the Wall Street Journal from 1992 to 1994. Okay? There's a particular data set that we'll keep referring to during this course called the Penn Tree Bank that University of Pennsylvania released about 1 million words parsed into what their individual formats with sentences that were taken from the Wall Street Journal from 1992 to 1994. And basically every single thing on the world in natural language processing has been trained on that data set. So it's great when it's actually talking about Bush as being president, and actually for other time in the 2000s that was good again, but it isn't. I don't think we'll have another Bush soon. Well, you never know. Okay, but you know, it's sort of out of date, and also not just out of date. You know, that's quite a long time ago. It's not quite 30 years, but it's definitely more than 25, and the language changes. Okay. As you'll hear during all of these lectures, I'm British, and at the moment I'm European. But there's this big event that's happening in the United Kingdom during this semester where I may no longer be European, and that is called Brexit. And Brexit didn't exist in 1992, if only they could go back to 1992. Although, were we even in Europe in 1992? But that's a different question. So Brexit, which is in the news all the time, at least in the UK, but you know, it's going to affect the whole world, isn't in 1992. You know, Donald Trump's not, well, Donald Trump probably is in the newspapers in 1992, but not as president. Okay. Actually, Boris Johnson might be, because he was mayor of London at some point in the 90s. I can't remember when. But you know, things change. The language changes. But independent of the fact that the language changes over time, it's newspaper text. Newspaper text is mostly written in the past tense. Okay? It's not written in the present tense. A number of Wikipedia entries are written in the present tense. It says things like, so-and-so is something, something, something. Okay, so it's talking in the present tense. Newspapers are usually reporting something that's already happened. So there's actually surprisingly little present tense in newspapers. So everything is better at doing past tense than present tense. Okay, and although the Wikipedia entries are sort of well written like a newspaper, they're not really the same as a newspaper, and therefore they don't have the same distributional properties is what newspapers have, so they're a little bit inappropriate. Now, we are doing Wikipedia, which makes things a little easier, and the part-of-speech tagger will sort of work pretty well, and when it doesn't, there probably isn't a good solution to it. But, for example, when we're doing things like analysis of social media, and we're dealing with tweets, okay, we might think that tweets are written in English, but anybody who's read tweets knows that they're not written in English, they're written in Twitter speak, okay, which has some English influence in it. But it also has emojis in it, and they're not really English, and it has URLs in it that are not really English, and it has interesting misspellings because people don't care, and it has interesting misspellings because people really care. So you have to sort these out, and part-of-speech tagging for Twitter doesn't really work, unless you use a piece of part-of-speech tagger that's designed for doing social media. Find all the occurrences of it is, or was, or were, okay, or some simple verb, and replace the subject with an appropriate WH word. This isn't very hard, but it's a really good start, okay, on how to be able to build a question system, okay, and so we strongly recommend that that's what you do first, okay. I hinted on this thing about which WH word should you use, and it's going to be things like what, when, who, why, and you have to choose between them. The why and the usually how is thought to be a WH word as well, even though it's an H. It's not. It's an HW word. But these question words are mostly are sometimes easy to get right and sometimes very hard to get right. Okay, and you probably want to build a classifier that tries to work out when it's easy and do it, and when it's hard, not do it and exclude that sentence. That's a perfectly reasonable thing to do. Yeah, so you want to know when you're doing badly and not include them. So it's sort of slightly different from other programming tasks. It's not, you must do everything. It's like, if you know you can't get anything out of this sentence, then skip it. There's other sentences. And that's probably a reasonable thing. You can't skip all the sentences, but skip the ones that you can actually do or know that you're confident that you can actually get right. Or output a score for it. And so when you sort them, you know the ones at the top are something that are actually quite reasonable. For question generation, I already talked about this. How many, does it get right? Does it get anything right? Or is it just all stupid? Okay, what's wrong with it? You have to do this technique of looking at the output to see what's wrong and then trying to find a way to be able to fix it. That might be something that you add to your machine learning system that's doing the classifier, or it might be a bunch of rules with regular expressions in them. It depends what the task is. It depends how easy it is to fix. It depends how general it is in order to be able to fix it. And you have to make a decision about that. You're trying to build a full system that actually does the task, and you're going to use machine learning to do some parts of it, and you're just going to go, no, I'm just going to get everything more than 10 words and not do them because they're always wrong. Or they're 80% wrong, so it's probably not worth it. And that's a very reasonable thing to do if that gives you a higher precision. Okay? And can you do something to fix the ones that are wrong? And remember, you put the filter in because maybe later you want to work on it and take out the filter and then see whether you have to modify the filter. Okay? It's a good idea when you're building any system of any form of complexity, especially one with multiple people in it, to immediately think about evaluation. Okay? Does this mean that every time you check it in or that you pull out the current version, you can type make test, it runs a test, and it tells you if it gives you the expected output? It's a really good idea to do that. You're all going to be doing different parts, and somebody sometime in November is suddenly going to remember something that Alan said about apostrophe S and change the tokenizer to pull off apostrophe S. And now it's going to break every other part of the system because it's something near the beginning. And therefore, it's going to break, and you want the next person who pulls everything out of the GitHub repository when they type make test know, oh look, that's what's wrong, okay? And you can fix it. When you actually want to deploy this, when you're actually going to give us the system, probably a Docker system to do this image, we would like there to be a good test system that we can do to confirm that it's actually working. It's just a good thing to do, okay? You know about software engineering as well, so it's a good idea to have an automated test. That doesn't mean that everything in the test gives you the right answer, okay? And every so often you have to change a test because you've now got a better answer than what you had before, and it's different what you thought was a good answer, and now you have to change your output accordingly, okay? But that's a good thing to do. Okay, there's a couple of restrictions that I want to try to remind you about. This class is NLP, okay? It's not a neural network course, and therefore we want you to do NLP in this. It is certainly possible to consider building a whole end-to-end system where the input that you give it is the end and the article, and what you do is you try to get it to learn how to output questions, okay? That is sort of a reasonable thing to do, but we do not want you to do that. Okay, why don't you want to do that? Because we want you to use the NLP techniques that we've been teaching in this class to do this project. Okay, you would need an awful lot more data to try to do that full end-to-end system. Okay, and so immediately you're going to search on the net and look for question answer type systems. You're going to find a system out there, a data set out there called Squad from Stanford, and you're going to go, yeah, I'm going to train everything on that. And the answer is, no, you're not. Okay? Well, you can, but it's not going to work. And it's not going to work because we give you a restricted article every time that you have to get the answer from. So that would mean you'd have to train it just on that article when you get the question. And then broad, tight techniques are not going to work because you've only got one article, okay? And yeah, maybe you could try to make that with pre-training and try to, but don't do that because that's not what we're trying to do. We're not just interested in your performance in this, we're interested in how you go about doing it. So we are expecting you to do things with parsing, with manipulation of the words, with scoring for questions and making sure that language models. Within that, it's quite likely that you're going to use neural nets, it's quite likely you're going to use word embeddings and various neural technology to do that. The end-to-end system almost certainly is not going to work. And I know you're thinking about, oh, it's just that old professor at the front, he doesn't understand how these things work, okay? And the answer is, oh, I really do understand how these things work, okay? And even though, if it was possible, I would be impressed, okay? But if you're capable of doing that, you also know how hard it is. And that's not what we're testing here. So we're not saying no neural nets, we're saying don't think of an end-to-end system because it would be really hard to do this. And it's also not what we're asking you to do. We want you to use the NLP techniques to do that. We want to learn what they do to help. They don't always help in all NLP systems, but they often help, and we want you to understand that. Okay? And we want to see when you build the system that you've understood the techniques that we're telling you about. Okay? And if it's a big neural net and we can't look inside, we're just actually going, no, yes, you have to describe the architecture. You'll still be using it. The other thing that you're not allowed to do is you're not allowed to say, when you get the questions, is you just write a little script that uploads it to Google and gets the answer back from Google. Okay? And the reason you're not allowed to do that is the people who do question answering at Google used to be in this class. Okay? And so that's using their system, well, it's not really using their system, they've got a much bigger system. But you're not allowed to use somebody else's question answering system to answer things, for obvious reasons, okay? You can't do that, okay? You are, okay, unlike for most of the homeworks, apart from when we explicitly say otherwise, okay, you are allowed to use toolkits that are already in existence. In fact, we expect you to do that, okay? We don't expect you to write your own parser, your own dependency parser, your own speech tagger. We expect you to use one of the tools that are already there. Okay? There's two particular tool sets that are out there that contain really good information. There's other things that are sort of close to them but not quite them, and that is absolutely fine to use for the project. In fact, if you don't do that, that's a little weird. Okay? So NLTK is a Python-based toolkit out of Berkeley that's really pretty good for most things. Lots of research things that come out of Berkeley and elsewhere end up going into that toolkit. It's definitely something that's worth looking at. The Stanford Core NLP kit is also really good, and sometimes you want to use both, and they sometimes interact with each other, because you know these Californians talk to each other all the time. They're not all done by Californians. Most of the Stanford Core NLP kit is written in a programming language called Java, but none of you are old enough to remember that programming language. But that's perfectly fine. There are Python wrappers for them, so you don't have to care about it. No, it's absolutely fine. Whatever you're comfortable in, we're not going to have any restriction on what programming language you're going to use. In fact, it's probably going to be multiple. That's perfectly reasonable to do that. So we are expecting you to make use of these toolkits, okay? But remember, the fundamental thing in the project is we're trying to find out whether you're understanding these NLP techniques that we're going to talk about over the next semester, and if you're just using too many black boxes without understanding the consequence, that's not good. Even if you get a good score, because we're not just looking at the highest scoring system, we're also looking at what did you choose to do that. So be aware of that. You can use neural nets. Neural net classifiers are probably a thing you're going to use. It's a perfectly reasonable technique to do things. Definitely word embeddings, which may or may not be neural derived, depending on which word embeddings you're using. is a good thing to use. In fact, you'll probably really want to use that. We'll talk about these things later, about what their advantages are, but it's a good way to be able to deal with the noise that's in different word meanings, so you can get better distance metrics between them within some sort of continuous space. You have to pre-train them, okay? So, it's maybe using Google Word2Vec or BERT to be able to get some sort of embeddings or glove. Or you pre-train some classifier to choose between what, when, why, how. You theoretically, at runtime, could do training, but that's probably a little risky thing to do, and I sort of wouldn't recommend it unless it's really fast. So if you're training anything, you want to pre-train it and only do some sort of adaptation with the articles that you get when you're actually running the system. Okay, so you want to be able to run this on a big GPU cluster at runtime, because we are going to do restrictions in the amount of time that you're going to run. So let's come to what actually happens at the end. So at the end of the semester, or near the end of the semester, around about Thanksgiving, you'll have to submit a real system. We're going to do this twice. Once is a dry run. You're going to submit a system to us. We are going to run it, and so you have to follow the rules about how to be able to run, the names of the commands that are actually going to be able to run these things. You're going to, last year we did this all with Docker. That was a perfectly reasonable thing to do. So you get to install everything that you actually need, the right versions of Python, the right versions of the libraries that go with it. As you saw from the message from David Mortensen, when I say Python, I mean Python 3. There is no other Python. Okay? In spite of what we've been using for thousands of years, well, maybe not thousands, well, last millennium at least. There's only Python 3, okay? You install and make sure that it works, and make sure that you have a test that when you run, that you're confident that it actually runs, and we rerun it, and we run that thing, it actually works. It doesn't output stupid things, the standard output, because it's going to break things. Then at the actual test time, you're going to submit your final system, and we're going to run it, and we'll have a bunch of machines to run it on, we will take into account how fast you're running as well, and there will be a limit on that. You're all going to ask me what the limit is, and well, put it this way, we have to run, I don't know, 30, 40 different systems, okay? Yes, we can run some of them in parallel, but we're not going to run all of them in parallel. We're not going to have weeks to be able to run them, and it should run at a reasonable amount of time. Remember in the previous year, one system took about 5 times longer to run than anybody else's. Well, most people's systems were through in tens of minutes, maybe an hour. One system took 24 hours to run, and they won. They got the best result. And then another year, there was another system that was something like about 36 hours, and we kept thinking there were bugs in it, and we went back and said they were doing the right things. They were doing the right thing. And after 36 hours, we got all the results from it, and they did not win at all. So, amount of CPU time is not really what makes the difference. We don't really care about efficiency much, okay? But we care about it a little bit if we have to get the results out. So, don't overly use that. And probably if you have to ask how much CPU time can we use, you're using too much. Okay? So, bear that in mind when you're looking at that. As I said, in spite of the, in addition to the, competitive competition that we'll have at the end, you also actually have to have a mid-semester report and an end report by video. Okay, so the way we do this, instead of having you all come up here and individually presenting, we get you to do a video that you upload privately to YouTube, and we watch it. There will be a link on the website to a YouTube video from a bunch of winners, actually a few years ago, and you'll get to see the sorts of things, and you'll get to actually see some of the techniques that other people have used. And you are allowed to use other people's techniques if you cite them. You have to say where you got it from. You're always allowed to use other people's forms if you cite them. in this project. In the homework, you've got to do your own work, but for the project, you can use other people's stuff. However, if you go and search GitHub and you find some question answer system for CMU's 11.6.11 from last year, you're not allowed to use that, okay? Obviously, okay? Well, you are allowed to use it, but those people that wrote the original will get the A and you will not, okay? So, you know, be sensible about it. We are trying to evaluate what you've learned from this, and you should be trying to show off the things you have. And you just copy somebody else's architecture and not do anything newer with it, that's not interesting, okay? But if you do something novel, or if you say we use these techniques that were mentioned by somebody else, but we made them better, and this is how much better we made them, that's really cool, okay? That's something that's going to convince us that you understand what you're doing and you're trying to improve it. And it's also something that will convince your boss when you go to a job out there in the real world. Okay. A couple of final things. All of you who can get into the class should already be in the class. We did another pass today to let people into the wait list. Okay, if you're not in the class and still on the wait list by tomorrow, please contact one of the TAs and we'll start trying to debunk what's going wrong. Okay, and we all know the system does funny things, and sometimes it can only be actually fixed by something called a piece of paper and some signature, and we'll try and work that out. But I think after today, everybody, you should get in, or if you know you're in too many classes, then you understand that that's actually the problem. So that should be clear. Oh yeah, choose a team name. Now, we said you could use any name as long as it can be represented in Unicode. But you guys are way too good at that, okay? And so you're not allowed to have a name that's backslash, close quotes, close parenthesis, semicolon, drop table. So please don't do that, okay? We also had, last year or the year before, we had two teams with the same name, okay? How do you stop that? I don't know, and we didn't notice because it was almost the same name and they didn't write the name exactly the same way with the beginning or not. And so please don't do that either if we suddenly come and say to you, are you the same team? Also, there'll be a sign-up sheet where we want to know which team you're in. And the other thing that we really need is your Andrew ID associated with the team. You've all got really interesting names, and I'm not trying to get rid of your names in any way, but you all have too many names, and it's really hard to try and trace at the last minute about, you know, somebody who's called Y Wang. I'm really sorry if there's somebody in the who's actually got the first initial Y and the family name Wang. Okay. You do have the highest Google Scholar H-index of anybody on the planet if you've got that name, because that's the one that's got the highest, because there are too many, which I thought was utterly ridiculous when I had it, but I've got 4 different co-authors called Wang Wang, okay? So please put your full Chinese name. If you use an English name, use that too. Put your full name in, but we want your Andrew ID. The whole purpose is so that we can index everything by Andrew ID, so we really do need that. We can't guess your name. We can't guess whether you're using a Western name or your family name. And also, you know, even if we know all your names, you know that the Andrew ID system just gives you a stupid mismatch of all the characters. It's got nothing to do with your name. So we can't do that. So make sure that that information is actually there. Okay? I'm going to give you, although we're almost run out of time, time to talk to other people if you want to try and find other people for your team. Okay? If you're interested in finding other people in team, please come to the front at the end. And if you've already got your team, move to the back. Okay, so the people who are more down the front are going to be more to do with those who don't yet have the teams, and go and actually see if you can find team members. Okay, thank you. No. Okay. Yes, maybe at the end if something was wrong.